Hello, welcome to Brains Tutor. So today we'll be analyzing the forces on an inclined plane. Last class or last video we did the analysis of forces on a rough table. So today we'll be analyzing forces on inclined plane. So the first thing we need to know is that the weight of an object is always acting downward. The weight of an object is always acting downward, and then there is a reaction that acts on the table, and this reaction is always perpendicular to the plane of action. So this reaction is always acting perpendicular, so you can see it is perpendicular. Let me change it. Okay, it is perpendicular to the plane of action, and we can see that this weight is now inclined at angle theta to the plane to the reaction. So we can see that this our weight we now have two components. That is, it's going to have the y component. The y component, since this angle is inclined at angle theta to the weight to the vertical, so it's going to be w cos theta, and then it's going to also have the horizontal component. So this horizontal component is going to be w sine theta. So that is for the weight. So the weight, as you can see, is going to be having two components, the wy, that is the vertical component, and since the angle is inclined at angle theta to the vertical, that is the weight, is going to be w cos theta, and then it's going to, in the x direction, that is the horizontal direction, is going to be w sine theta. So the next thing we need to know that is that an original force Fm. So Fm is the force that is initially applied to move this block up this inclined plane. So if it's being moved up this inclined plane, it is going to be obstructed by the wx, and since this block is a rough inclined plane, it's going to be obstructed by another force. This force is called the frictional force. And the frictional force is equals to the coefficient of friction multiplied by the reaction. So the moving force, that is the force that was initially applied to this block, is now obstructed by two things. The first one is the weight in the x direction, that is the wx, and then it's been reduced by the frictional force, that is the fr. So, and it's now going to, it means the force that is actually going to move this block is going to be the net force after it's been subtracted by fr and wx. So to balance this off, we are going to be resolving both vertically and horizontally to resolve all the forces acting on this block. So the first one we'll do is resolving horizontally. So resolving horizontally, we will see that Fm, we will see that the original force that was applied to the block is now being reduced by the frictional force. It's being reduced by frictional force, and is also being reduced by the weight in the x direction, and then that is the x component of the weight, or the horizontal component of the weight. Then it's now going to give us the net force that we call the force of acceleration. So let me quickly define all the terms here, where Fm, this Fm is called the original force. This is the original moving force. Then Fa, this is called the force of acceleration. And then this is given as the mass times the acceleration. That is the acceleration that is used to pull this block up this inclined plane. And then we have the Fr. The Fr, this is called the frictional force. So this is an opposing force, the frictional force. And then the frictional force, to get the frictional force, it is defined that coefficient of frictional force is equals to frictional force over normal reaction. So if I make frictional force the subject of formula, I have it to be coefficient of frictional force times the normal reaction, and that is what we have right here. So that is what we have right there. So the next thing we need to define is, okay, the W is the weight of the block. And then theta gives us the angle of inclination. So I think these are all the terms right here. So if I need to put some terms, I need to substitute some terms into our equation right here. So this equation, I'm going to denote it by equation 1, because we are going to be referring back to this equation. So what will now be our value of Fm? Or before we put all the values of Fm, Fr, Wx, let us resolve vertically. So resolving vertically. So the only forces that are acting vertically here is the first one, which is R. R is acting vertically, and then Wy is acting vertically. Just that this one is acting, R is acting in the upward vertical direction, and Wy is acting in the downward vertical direction. So to balance this force, R needs to be equals to Wy, and Wy equals W cos theta. So we can call this equation 2. Okay, let's call this particular one equation 2. Alright, let's call this equation 3. So what we are going to do is we are now going to put all the values of Fa, we are going to put the value of Fr, we are going to put the values of R itself. We are all going to put it in equation 1. So going to the next page. So our original equation, that is Fm, is reduced by Wx and Fr, which gives us the net force Fa. So Fm, I need to substitute all the values now. So now what is Wx is right here. Wx, that is the weight acting in the horizontal, for the horizontal component. You can see here Wx is W sine theta, so we have it to be W sine theta plus Fr. R is the frictional force, and I think I've explained that frictional force is equals to mu R. So I write mu R. Then mu R will still impute the value of R equals Fa is the force of acceleration, which is usually equal to the mass times the acceleration that is used to pull the block. So if I further put the value of R into this equation, I have my Fm, that is my moving force, minus W sine theta plus, this is the frictional force, I have it to be mu. Then R equals, let's check the value of R. From here, R equals W cos theta. So I can impute the value of R to be W cos theta. So everything gives us Ma. So if I want to find the moving force itself, moving force can be equals to Ma plus W sine theta plus mu W cos theta. So yes, so that is how we resolve the forces acting on a block on an inclined plane. So we can check it all again. And if you have any comment or any question, or there is something not clear, here is my contact, or you can drop your questions on the comment section. And if you need some personal tutoring, my details are on the screen. You can always message me and we can get to work. So these are the forces acting on an inclined plane. Now in the next video, we are going to be solving questions related to the inclined plane, and you can also check the question we solved under the forces acting on a rough table, on a plain horizontal table, so you can check it out also. So thank you very much and see you next time. Bye.